So the first method we learned for solving quadratics was factoring. So to review, to solve a quadratic by factoring, you want to make sure the quadratic is set equal to 0. You want to factor. Then you want to set those factors equal to 0 and then solve for x. So for example, number 5, let's go ahead and set this quadratic equal to 0 by subtracting 26x on both sides. I can take out a GCF of 2 to start the factoring process. So x squared minus 13x plus 40. And I can factors of 40 that make negative 13 are minus 8 and minus 5. Set each of these factors equal to 0 to solve for x to get answers of 8 and 5. So those are the x-intercepts or the solutions to the quadratic in number 5, and I solved that by factoring. The next method we learned was solving by using square roots. Keep in mind that this is only for quadratics that have no bx term. So the steps for solving by square roots are as follows. Isolate x squared and then take the square root of both sides. Don't forget plus or minus when you take the square root of both sides. This is also the first time we see the potential for no solution. So if you do your math correctly and you end up with a negative number underneath the square root sign, that is automatically a no solution because there is no such thing as the square root of a negative number. So for this section, I will do number 10. Since there is no bx term, we can solve by square root. So isolating x squared by subtracting 1 on both sides. Multiplying by 4/3 to cancel off, why is my pen not working there? Multiply 4/3 to cancel off the 3/4 on both sides. Okay, so those cancel. And I end up with x squared is equal to 40. Take my square root, because we're isolating by solving by square root. So x is equal to plus or minus the square root of 40. You also have to know that that is not simplified, and simplify that into plus or minus 2 radical 10. That comes from the square root of 4 times the square root of 10. So x is equal to plus or minus 2 square root of 10. The next method we learned is completing the square. To complete the square, you want to remember that a has to be equal to 1. And if a is not equal to 1, if a is greater than 1, you want to divide off a in the entire problem before you start completing the square. So the steps for completing the square are lengthy, and here we go. So to complete the square, you want to move c, half and square b, add that number to both sides, factor the left, fix the right, square root both sides, don't forget your plus or minus, and then solve for x. Remember for these that also if you have a negative under the square root that you have a no solution. So if you want to try 13 on your own, that one will end up being no solution, and you will see that when you solve by completing the square. But I'm going to go ahead and do number 12. So let's move c by subtracting 55 on both sides. And 3 minus 55 is negative 52. So now we're going to half and square b. So x squared plus 16x. Half is 8, sorry. Squared is 64. And we're going to add that to both sides. So remember that you half and square b, and you add that value to both sides. Factor the left, fix the right. And if we factor the left, we get x plus 8, x plus 8. That's a 12. I don't know why my pen is doing this. Okay. Now that you have your 12, you could take the square root on both sides, and we get x plus 8 is equal to plus or minus the square root of 12. Subtract 8 on both sides, put that right there. So x is equal to negative 8 plus or minus. Let me go ahead and clean up the square root of 12 into 2, square root of 3. That is coming from the square root of 4 times the square root of 3. Final answer. Last is the quadratic formula. And you just have to remember that you want your quadratic in standard form so that you can identify the correct A, B, and C to then throw into the formula, which is negative b plus or minus square root of b squared minus 4ac all over 2a. Also keeping in mind that if you end up with a negative number underneath the square root, it is no solution. But just double check, because sometimes you forgot that a negative and a negative make a positive. So I'll do number 18 as an example. Let's get that in standard form first by subtracting x and adding 5. A is 3, B is negative 10, and C is 5. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So I'm going to clean up with the arithmetic here. So we have 10 plus or minus the square root of 40 all over 6. To simplify, we got to simplify root 40, so that's 10 plus or minus 2 square root of 10 all over 6. And my last simplifying step is to check that the 3 of these either can or cannot reduce, so all or nothing. And they can. So final answer of 5 plus or minus square root of 10 over 3, because we reduced all of these by 2. So that concludes our review of the 4 methods. What we're going to do now is we're going to jump over to talking about how to choose which method is best and fastest for solving each quadratic. So turn your notes over to this page, choosing the best method. And let's start taking a look at what we've got. So for choosing the best method, one best practice is to always start with your quadratic in standard form. That will help you to quickly assess which of the 4 methods is best. So let's talk about factoring. Factoring is best used when the equation is factorable. If it's not factorable, then factoring is not the method for you. Square root method is best used when there is no bx term. So if there is a bx term, you can automatically throw square roots away because that's not the method for you. Now we can always complete the square or use the quadratic formula, but sometimes one is faster or easier than the other. Completing the square tends to be faster and easier if your a is equal to 1 and your b value is even. Because when you half and square b and you have an even number, you can avoid fractions. If b is odd and you half it, you're going to end up with a fraction. So that would be one of those scenarios where like, I'd rather just use the quadratic formula. So the quadratic formula is for all other cases. Now these are not hard and fast rules with the exception of these 2. Obviously, if it can't factor, you can't use factoring. And if there is a bx term, you can't use square roots. You can always complete the square and use the quadratic formula, but they may not always be the best option given the amount of time you have. And one thing that some people struggle with is how to tell quickly if a quadratic is factorable. So there's a trick. If you find the discriminant really quick in your calculator, and that discriminant is a perfect square, then that quadratic will be factorable. Yep, mind blown there. So if you weren't sure with guess and check whether or not the quadratic was factorable, a real quick b squared minus 4ac, either pencil paper or with a calculator, and if it comes out to be like a 25 or a 49 or whatever, if the discriminant is a perfect square, then that quadratic is factorable. So that's just a hint. If you aren't able to tell, some people can tell just by looking that a quadratic is factorable, some people can't. If you can't quickly tell if it's factorable, this is a quick check if you know that hint. So we're going to choose the best method here. First I'm going to put this first one in standard form. Okay. If you find the discriminant here, you'll see that the discriminant is 300, which is not a perfect square. So this is not factorable. We can also tell it's not factorable because there are no numbers that multiply to make 66 that will also add to make 6. So it's not factorable and it has a bx term. So our only options here are completing the square and the quadratic formula. And at this point it's a matter of preference. You know, a is 1 and b is even, so if you like completing the square, you can do that. or you can just go straight for the quadratic formula. For number 2, it has no bx term, so we can go square root, but it's also a quick factoring of the difference of squares, 3x plus 2, 3x minus 2. So obviously, all methods work, but these two would be the fastest, factoring or square root. On number 3, let's put it in standard form and then decide. Now, some people may quickly see that this will not be factorable. There are no 2 and 1, 7 and 1. It's not going to make an 8, okay? But if you don't see that, find the discriminant. Find the b squared minus 4 times a times c. And the discriminant is 8. Since 8 is not a perfect square number, then this is not factorable. It also has a bx term, so I can't use the square root. So my options are completing the square and quadratic formula, but a is greater than 1, so that means I would have to divide off everything by 2, and I've got that 7 there, and 7 divided by 2 is a decimal, or 7 has, I don't know if I want to complete the square either, so I think the best choice is going to be quadratic formula here. And for number 4, you've got 2 and 7, and that does make 9. So factoring is the fastest and best way to go. You definitely can't use square roots. If you wanted to complete the square or use the quadratic formula, you could, but it's kind of a waste of time when you can quickly factor and get answers of -2 and -7. So use this as a guide as you work through homework 12 problems and you kind of have them all mixed up and you're trying to decipher which is the best method to help you be as efficient as possible. In homework 11, you are asked to do specific methods at specific times. I would do it specifically so that you practice each method and become more fluent in each of the methods. Thanks for watching my video on reviewing the 4 methods for solving quadratic equations and choosing the best method.